Welcome back, everyone. It's been quite a while since I've posted on YouTube and almost as long since I've posted on our paid subscription channel. Now, the paid channel does have forums, so I've been updating on there. We've got a t-shirt giveaway and all that stuff, but it's still been fairly infrequent with the uploads. I was looking at the last couple of videos we did where I was doing some on the Merlin, which really isn't the primary focus of our Typhoon project. And it was quite laborious for me to put together, and there really wasn't that much interest. So I've been working quite a bit on things that really aren't currently video worthy, that take a lot of administration and a lot of my time sitting in front of a computer or making connections and deals with vendors. But I hope that that's going to pay off fairly soon and that we can have some really very cool outsourced projects that we can show you some video work on that's actually Typhoon related. Now, one of the big developments that's happened since the last video was published is Typhoon related. Trust me, it's got some bearing on the Typhoon. But it's, if you remember the Alfa Romeo engine that was at the back of the shop, the license-built version of the de Havilland Gypsy Queen, I had purchased that to basically save it, possibly from the scrap man, and it just sat there collecting dust. It wasn't applicable to the project at all, but I wanted to see it go to a good home, and I think we found a good home for it. We also had this Canadair Argus prop sitting on the table here that was donated to us, an amazing contribution, but again not related to the project. So we've bundled those up. We've found a new home for them where the public's going to be able to see them, thankfully, and we made what I think quite an amazing trade. So that would be this. Some of you may recognize this. We did a little bit of fun on the Facebook page, which actually went really well, so I may do more of them. A bit of a teaser trying to get people to guess what this was. It didn't take anywhere near as long as I wanted, but it was fun for everybody involved, I'm sure. So some of you, quite a few of you, likely know that Bristol was essentially ordered by the Air Ministry to share their single sleeve technology with Napier, as Napier was developing the Sabre and having issues with sleeves warping and engine seizing. Bristol wasn't happy about that, of course. They spent millions and millions of pounds developing their technology from the 30s right through to the beginning of the war, and were obviously quite reluctant to do it. They did, however. There was a war on and a lot of pressure to do so, and that technology ultimately led to a much more reliable Sabre and potentially could have saved the Sabre program. Now, to do that, what Bristol did is they took the Bristol Taurus engine, of which this is one, which shared the same bore as the Napier Sabre, which is 5 inches, and they took the blanks, blank castings for the Taurus engine, and they were machined for the Sabre, and this ultimately solved the warping problem that the Napier Sabre was having. But this is a Bristol Taurus. It's a 14-cylinder sleeve valve engine. Development started in approximately 1936. I don't know how many survivors there are of these, but it's not very many. It's a neat piece of the development of sleeve valve technology, single sleeve technology, and it's a very interesting link to the Sabre development. We've got 2 of these guys. They came from a Bristol Beaufort. Actually, they came as spares from Bristol Beauforts that served on the west coast of British Columbia during the war. I think Canada only had about 24, 25 Beauforts. I believe they're all Mark 1s, Taurus powered. Ferry Albacore is also flown by owned by the RCAF. As far as I know, there's only about 6 of those, and I don't know if they ever got unpacked from their crates. I'm not sure what happened to them. They were written off, but I've heard stories they were never uncrated. So it's not a common engine here either, but these 2 were spare engines for the Beauforts on the west coast, and they were sold war assets to a scrap yard where they sat for years. You can see this is the frame of the crate that supports the engine inside. You can see on the bottom there is a piece of the wood left over from the crate as well. And they essentially just sat outside. The crates must have rotted away or broken away, and it looks like to get them around or move them out of the way, they rolled them around a couple times. So there's a bit of damage to some of them, but essentially they're still 2 pretty impressive engines, and I really look forward to learning more about these. For now, side project. Get this engine out of here and get something going on with this engine and get back to the sheet metal on our monocoque section for the next exciting phase. I'll do a little update on the Merlin here as well. As you can see, things, I mean, there's not a lot of visual progress with it. We've added the mounts for things like the fuel filter, the oil filter, There is the oil cooler mounted in there. The tanks are mounted with the pucks. I think I've shown that before. Rob has done extensive work on the throttle linkage, which is excellent. It's quite a complex little differential unit and very cool to be watching it as it gets solved. We've made some progress with both spark plugs, plug leads, and the sneaky little Bakelite pieces that go in the magneto, as you can see right there, are on the way thanks to the Bomber Command Museum of Canada, as well as a tachometer. We had some serious issues just trying to locate a tachometer that we could use mechanically pulled off of the valve cover on the Merlin. And unfortunately the one that we have is broken and we can't use that one. We pulled it apart and it had some sort of catastrophic failure internally. So again, thanks to the Bomber Command Museum of Canada, they're sending us a tach generator that's going to allow us to use an electrical tach, and it changes the ratio, which was the big problem on this, to a more common ratio. So little problems like that can take a lot of time, but good friends really do come in handy and really make these kind of projects happen. Word is that our propeller is also underway now, which is kind of the last item. We hope to have this all plumbed in by the time that the propeller is complete, and we might even be able to give it a quick test run or do some troubleshooting before the prop shows up. Another major acquisition for us is this 4-foot 12-ton press brake. And this isn't a purchase. This is a very generous donation from our sponsors over at Pyrotech Aerospace in Abbotsford, British Columbia. And it's going to go a long way to the work that we're doing here on JP843. Our manual box pan brake here is excellent and covers off a great deal of the straight bends that we do here in the shop. But the versatility of having a 12-ton press brake is substantial. And it's going to really help us out with some of our more complex, either deep bend box sections or heavy gauge stainless steel bends. Before having a piece of equipment like this in the shop, any of the work that was beyond the capacity of our box pan brake would have to be done in special tooling. And it's special tooling that we can produce locally, and in fact we're starting to develop a bench mounted press brake that used a 12-ton hydraulic cylinder and would be able to hold fingers just like this one does for a couple profiles that are used in the forward monocoque on the Typhoon. And there's parts of it kind of scattered around. You might have seen them in the background, but this particular machine will make it so much easier and so much faster for us to do that. We won't have to build this piece of equipment. The time that I commit to building stuff like that can now go on to other aspects of the project, and ultimately the Typhoon and everybody that's a fan wins. So thank you very much to Pyrotech Aerospace. This piece of equipment is going to be used for those projects like I say, and it'll be an instrumental piece of equipment for the production of the Typhoon's cockpit section with all of those stainless steel gusset plates. So amazing, amazing people over there, and I'll never be able to thank them enough for providing this to the project. An area of the project that never gets enough coverage is probably the most important aspect of the entire thing, and that's our CAD guys. The design team is instrumental in making this happen. In some of our early design videos, we touched on the fact that the cockpit section and all of the structures were a little bit wonky if you actually build them exactly to the drawings. And you'll find this with most warbirds. If you go back to drawings from the 30s and 40s, they're all done by manually lofting, so there could be some very, very small issues in it. Those issues were ironed out by the tooling guys or the fitters on the floor, and often the changes that were needed didn't make it back to the design phase, so the drawings just remained off. Now, to produce to exact drawing requirements would be leaving small flaws in areas that would need shims and little bumps and lumps and things like that in a structure like the monocoque. Thanks to CAD, the work that goes on for sometimes months or years while other things are in the limelight is all ironed out, and we have a model that can be fit and verified before anything tooling or component wise is produced. So I'm sure you've seen this monocoque structure sitting here for quite some time. I've been off it while I'm tiddling with the, the Merlin here and building a trailer while Rob does the mechanical side of it. But during this whole time, and even years prior, the cockpit section has been underway from the CAD and the development side of things. And it's really picked up now with my father doing the verification of the cockpit. All of the finite details, bolts, nuts, washers, distance tubes, and man, there's a lot of those things. They're all being either created and verified and put into the assemblies to make sure that everything just functions perfectly. There's also little things like where if we take one of the tubes and the new tube wall thickness is 1/1000th of an inch thicker than the old wall thickness, we need to make adjustments to the hardware, distance tubes and other, that go into the assemblies around that. So if we don't do that, even though it's a very small amount, there's going to be stacking errors that tend to build up, and they'll catch you when you least expect it and when you don't want it. So this work has been ongoing for a long time. It's really getting close to the end, but it's amazing to see this come together. With the cockpit design work, verification, bills of materials, all full steam ahead, I really needed to get a little bit of catch up in there with all of our engineering and documentation to make sure that our actual material specifications, when we get into the production side or repair side of all of those components, is exactly what it needs to be and isn't going to cause us any problems. So this is another thing that I've been working on. It's not fun looking at me creating spreadsheets or discussing metallurgy with engineers, but it's something that is absolutely necessary so that we can transition smoothly from our monocoque section into the cockpit section. The monocoque structure is essentially the same as the last time I did any video work on it, with the exception there's a box underneath it. I've made some arrangements for our sponsor Sealand Aviation up in Campbell River. They're going to be doing a little bit of router work for me because the forward monocoque front end ring is going to be changed. JP843 was built as a car door type Hawker Typhoon. And when they went and modified it to a sliding hood canopy, it had a front end ring that was designed specifically for retrospective action. Now the design that we used originally when we did our production fixture was the standard production variant of the front end ring for the sliding hood. Because JP843 was modified and everything must be exactly as original, we're going to modify the front end ring station plate. We've got the components cut out, and I'll make sure that the front end ring is built exactly to the standard that JP843 was. So the transport joint is made up of two frames at the aft end of the forward monocoque and at the forward end of the rear monocoque. These are frames K and L. And originally the Typhoon used a frame in both locations that was exactly like these guys, obviously a different profile to fit a different location within, but this same materials, the same patterns, all that good stuff, and they were separated by 2.1 inches apart. The only thing that held those two sections together was a strap in between them, and this is what led to the tail failures. It wasn't the cause, but it was the weak point that the stress concentrated and the tails fell off. Now, Hawker ended up fixing that with a series of modifications to the aircraft, and ultimately they put fish plates on the outside that actually carried the loads across the stringers. This design stayed in place right through to the Hawker Tempest 5 Series 1. So all of the early Hawker Tempest 5s used the same sheet metal frames, spaced 2.1 inches apart at the transport joint on the Typhoon. Only with the Hawker Tempest 5 Series 2 and all Hawker Tempest Mark IIs did they switch from these sheet metal frames at the transport joint to an extruded frame. So the extruded frame was, in my opinion, a much more sound design in that it was two extrusions placed face to face and bolted together. So definitely a stronger joint, and it's the one slight alteration that we're going to make in the rebuild of JP843, in that it's a major safety issue and it just makes more sense. So Hawker Typhoon JP843, while not fitted with it originally, will be fitted with the transport joint made from two extruded sections. Now they're different again in the fact that they all these are quarter frames, and the transport joint made of the extrusions was just two half frames that were butted together and riveted in the middle. So to build these, they are, from memory, 0.11 inches thick, 110 thousandths of an inch, and they're also in T3 or T42 condition and will require forming to take the contour. If you notice the shape of the Hawker Typhoon fuselage, it's going to be an oval, and you've already got a compound curve there if you're stretching an oval on a 90-degree channel. But then again, the frame K on the forward monocoque side also opens up to fit the expanding angle of the monocoque itself, whereas frame L will taper backwards with a closed angle on that same extrusion. So to get all of these different shapes involved in it, the ideal way of producing these pieces is to stretch form. The initial stretch form plan was actually to build a small stretch forming machine in-house to pull and wrap these extrusions ourselves. But we've actually switched that plan. The materials are still here. I still want to build that equipment for some of our lighter gauge sections, but this was definitely worth handing over to the professionals, and they were kind enough to help us with this as well. So we've got a team of companies that we'll be talking about in a future episode that's going to deal specifically with this.